we will deep dive into 3 of the subjects that we talked a little bit about in the first opening ceremony, which is sustainable blockchain, AI in healthcare, and confidential computing. And we have 3 fantastic experts with us in the studio. My name is Anna Petersson. I have the role of Head of Innovation at the Future Arena of High5, and I have the honor to guide you through this 45 minutes together with Erik Behm, who is a strategist at Invest in Halland, who you will meet very soon. All of you, both in the studio who are here with us, and those of you who are visiting this event digitally, are more than welcome to ask questions to our panelists and experts. And you can do that with a chat function, and our chat moderator, Lovisa Jakobsson, will make sure that we could lift in your questions to our experts. So with that said, once again, most welcome, and I will leave the word over to you, Erik, and our guests.
Good morning, and we have just had a Swedish inauguration, and then the first speaker was Fredrik Rinderud from Radar Group. Before we go into a little bit deeper, could you do a short recap? What trends do you see for the future here?
Well, as I said in my presentation in Swedish earlier, the trends are the usual ones, the usual suspects, but the ones everybody's talking about is of course AI, blockchain, and so on. But IoT, 5G, but the interesting thing here is to put them in a perspective, in the local perspective, to see how big are the investments, where are we on the hype curve or maturity curves, and why are we investing and how are we investing. So, for example, a bit of a recap from the presentation, but almost 50% of all Nordic organizations and Swedish organizations have some kind of investment this year in IoT. They have allocated funds for investing in IoT, and about 1/3 or a little bit more than 1/3 have investments in AI or machine learning and related technologies. But the investments are quite small. And 1 year ago, when we studied the actual implementation of AI, for example, in Swedish organizations, only 5.5% actually had implemented AI, as far as they knew. Then, of course, a few of them had some black box AI in other types of technology that came for free or without their knowledge, but only 5.5% used AI. So the trends are the ones you expect to hear when someone talk about tech trends, but when you put them in the local perspective and in a monetary perspective, we really need to ramp up here, because, as I said earlier on as well, we live in a high labor cost part of the world, and we need to excel when it comes to digital transformation. And to do that, the new technologies, such as the one I mentioned and a few more, are key to excel when it comes to digital transformation.
Shortly, we talk about green IT. You talk about green IT. Now it's sustainable ICT. But now you mentioned a 4th dimension of sustainability in security. Could you elaborate a little bit on that? Because it's very on the top thing about what happened yesterday with Facebook, etc.
Yeah, what happened yesterday is interesting because it's an eye-opener to everybody, people outside of the IT ecosystem and people not working with technology. But I mean, we have seen a number of breaches in the Nordics that have been recognized by media. The last one was a grocery store or a chain. But there have been several. A security company, a bit funny, that was exposed to ransomware, I believe, a few months ago or half a year ago, something like that. But the conclusion from my presentation was sustainability, but from actually 4 different perspectives. And that's really important when we go into this new world, so to say, or at least in this new tech era. we need to do that with open minds, of course, to adopt the technology, but also staying sober when we adopt the technology to adopt the technology and adopt the digital transformation in a sustainable way. And one part of that, or one dimension of that, is of course the cybersecurity dimension, where we have a war between economies in the world right now. We have one of the huge economies in the world who have this Belt and Road strategy, where they want to control different kinds of flows in the entire world, including, of course, the digital flows or the data flows. We also have regulatory issues or regulatory challenges with the big economy in the West, where they allow themselves to confiscate or look into our private data in a way that we're not happy with, of course, here in Europe. So the security dimension is one dimension. Another dimension that was mentioned in the discussion you had here a few minutes ago was the human dimension of it, or the social sustainability dimension of it. When we use the new technology, how can we use it? When can we use it? How do we benefit from it when it comes to, for example, AI in healthcare that we're going to talk about? Huge benefits, of course, but at the same time, there's also risk when we collect data, when we track people not only on location, but when it comes to state of mind, or how people live and feel and act on a daily basis. So there are a lot of ethical questions here. So sustainability from a number of different perspectives is really important when we adopt a new technology and the digital transformation.
Thank you. And our first speaker here is Sara Samani from Metabytes and the University of Halmstad. Yes. You go further into blockchain.
Sure. Hi, everyone. So I'm Zara. I work as Head of Disruptive Technologies at Metabytes, and I'm also a PhD researcher in blockchain adoption in small and medium enterprises in Halmstad University.
You can walk over to the presentation over there, and in the meantime, I'll also introduce you to Cobra Enetami, also named Asana. You will, after Sarah, you will talk about AI in healthcare, and we will get to know you a little bit better. And with us digitally, we also have Petko Karamochov, who is director of Industria, a tech startup from Bulgaria, who will talk about confidential computing.
Sure. Shall I just click here?
Yes.
Okay. So, hi everyone, and today we're going to talk about blockchain and sustainability, right? The two words that you have probably heard a lot, and you have probably also heard that blockchain is not sustainable. It uses a lot of energy and consumes a lot of energy, etc. So let's dig into that and see what is the reality behind the myth, right? So, but before that, we need to know what is blockchain at all. And a quick introduction to blockchain. So blockchain is a digital distributed ledger. I'm just going through the keywords and then I'll come back to them. That transactions are cryptographically sealed. They're chronological and timestamped. Blockchain is a decentralized solution. I mean, it's irreversible, immutable, all these words that you keep hearing about blockchain. But if you want to make it short, blockchain is that solution that eliminates central storing of data. So there is no central house of control anymore. And data is distributed among everyone that is part of the network. Let's imagine we're all part of a blockchain network. We all have the same copy of all the transaction that has happened throughout this network. It's always real-time updated and synchronized. The transactions are cryptographically sealed, means the transactions are only available to see the details by whom it is meant for. So if two of us are transacting data between each other, it's only the two of us that can see the real data. Everyone else will just see that the transaction is happening. So there is no breach of privacy here in blockchain, unlike what the majority of people think, that everything is publicly open to everyone, right? And then it's irreversible and immutable. That means you cannot change the past in blockchain, you can only make future in blockchain. You cannot touch what has happened before, you cannot manipulate with data, and that is because of the way the data is stored and the blocks are chained together, which we will talk about it shortly. So here, how does it work? Oops, sorry, I wasn't looking at there. So how does it work? In a blockchain network, any node, which is a computer, anyone who wants to start a transaction will broadcast that request to the network. And through some sort of consensus mechanism, that transaction is validated. Once it is validated, the block is shaped, is added to the chain. But what is consensus mechanism? Consensus mechanism is an algorithm that based on that, the network decides that this is a validated transaction. This is valid. This is okay. Let's go with it. Let's do it. And these consensus mechanisms have different types. We have different types of them. The first consensus mechanism that blockchain started working with was called proof of work. And that is the source of all the criticism against blockchain and sustainability. Proof of work was the consensus that Bitcoin started working with. And it's the consensus that it involves miners and computing power, etc. Through proof of work, in order for one transaction to be validated, once the transaction is broadcasted to the network, miners who are basically computers with higher computing power, who are willing to take part in validation of transaction, start all of them, imagine all the miners in the network, which are not one or two, start calculating, start solving a very difficult mathematical equation, which takes a lot of power, which consumes a lot of energy. But only one of these miners, who is the first one that can actually solve that mathematical equation, validates the transaction and gets rewarded. So all this power is consumed, but only one of them is rewarded. And the rest of them, the power that they use, is gone to waste, right? And here is a lot of challenges with sustainability, right? And it is said that, for one day operation of Bitcoin, the power consumed is equivalent to 1 month of a country like Poland. So this is not a small amount of power, right? And then this was the problem with sustainability and blockchain when it started. But after some time, when blockchain was working with proof of work, Ethereum started working. Ethereum is another blockchain that starts introducing decentralized apps, but we should call them dApps in blockchain world, to allow companies to build applications, etc. Then the criticisms started. But if that is how blockchain works, even though how amazing it is, it's not going to do much, right? And it's not scalable, because you cannot really consume this much power for all of for every transaction. Then other consensus came into the picture called, for example, proof of stake, which they work differently. They are totally green. They don't use any power. It's based on how much stake you have in the network. If you have bigger stake, you can validate the transaction, you have higher chance of validating transaction. Other consensus came, delegated proof of stake, which you can actually delegate your power of voting, your power of validation to someone else, or vote that someone will be delegated to validate a transaction. Proof of authority in private. So multiple consensus came that people often ignore talking about them, because it's more fun when we criticize blockchain as a non-sustainable and bring all these issues, right? It attracts more attention. But there are, of course, the major blockchain that works with proof of work is Bitcoin. And Bitcoin is actually not a blockchain that we can build any application with, surprisingly. So we don't build any application. It's Ethereum that majority of applications are built, and Ethereum started with proof of work, but has migrated to proof of stake. So Ethereum was the one that introduced proof of stake, and since December 2020, it's fully migrating to proof of stake now. So talking about this, how does now blockchain transform businesses? So blockchain, now that let's imagine we are in a blockchain world. Now we are in a world that we don't have any intermediaries because we are all directly connected. It's a peer-to-peer network. If you're working, for example, in retail, there is no wholesaler, there is no distributor, so you can directly connect to the manufacturer. Or if you're transacting money, there is no intermediary bank involved. It's from source to source, so it's very direct. Therefore, it reduces a lot of cost because you pay a lot of transaction fee to intermediaries involved in any business, in any industry. And when there is much little cost with using blockchain applications. And also, you save a lot of time. Because usually this process going through intermediaries in a business, in any industry, takes a lot of time. From continent to continent, today, transaction of money can take up to 10 days. And that means a lot for a small business. That can actually kill small businesses. So, and with blockchain, the slowest blockchain today is Bitcoin, which every transaction can take 10 to 15 minutes to happen. So even though we call Bitcoin the slowest blockchain, it is still much faster than today's banking system. So, and also the fact that it's irrevocable, you cannot change the past. That means it's always auditable. You can trust it. They call blockchain trustless operation, but that does not mean you cannot trust blockchain. It means you don't need to trust a central place. You don't need to trust the bank. You don't need to trust the headquarter office. You just need to trust the network. The trust is distributed to the network. Everyone in the network is creating that trust. And once it's auditable, of course, it enables businesses to be able to monitor what is happening. And it provides transparency to the public. And that is, again, the fact that provides transparency is one aspect that you can see it supports SDGs a lot, right? The fact that there is no intermediaries involved, that means that the resources can reach to the people in need much faster. That means the access to education for poorer areas can happen much faster. That means we can actually record how much water was consumed for production of a food. We can actually record, we can see realities transparent to us. Industry cannot play or manipulate with data anymore. So this transparency is a lot of power that is given to public. So I'm not good with time, so if you could just remind me. Yeah. Oops. Okay, and then we have, of course, different blockchains. We have public blockchains that everything is transparent to public. We have private blockchains for internal use within a company or organization, and we have federated or consortium blockchains that multiple companies come together like a supply chain, and they want to build their own blockchain, etc. And okay, then I will go to use cases. In general, for use cases of sustainability, you can use blockchain in supply chain, when you can track and trace the product from farm from very raw material to the end user hand. And that means you can actually, eliminate a lot of intermediaries. You can eliminate counterfeiters. You can support. You can help with against human trafficking. You can help against child labor with blockchain. So there's a lot of sustainability goals that blockchain can actually achieve if we don't only look at blockchain from energy consumption and don't limit blockchain to one consensus mechanism only. And of course, blockchain is growing globally, and we will see more of blockchains in governments and regulations, because that is the aspect that blockchain is still missing and lacking. So that's it, I think. Thank you, everyone.
Thank you very much, Sarah.
Sarah.
So this was a very quick introduction to blockchain. And for those of you who are interested, one of your master students will actually have a presentation on Friday, where she's been working together with you and Metabytes on a blockchain to save water in a chain of suppliers of water within the food industry.
To monitor water consumption in food industry, to both ensure the end users of how much water was consumed in production of food, but also show the power of blockchain in sustainability.
Yeah, so if you're interested, it's 1 o'clock on Friday where you can learn more about the specific case within blockchain. With that said, Fasane, we will jump into another subject, which is AI, and more precise, AI in healthcare. You are Associate Professor in Machine Learning at the School of ITE at Halmstad University. So I will leave the floor to you.
Okay, hello everybody. I think I've not presented my name and my position, so I will dive directly into AI in healthcare. As everybody know, AI has a lot of promises with it. Comes to the healthcare in specific, and I try to find some statistics over the AI research in healthcare, which is very growing fast. And I found some statistics which was very interesting. In 2016, among all other global economy, AI was the hottest category for deals. And you can see how the investments in the market globally has been rising like 10 times within less than like 6-7 years. And it shows the promising over AI in healthcare in specific. But where AI can really impact in healthcare? Healthcare systems around the globe are facing value challenges. The most recent one was the pandemic. Hopefully it's over, but we have seen the sudden rise for need in healthcare, which was not really balanced among the healthcare system resources and how many people are in need of healthcare. The second one, which is more globally affecting a long time, is the aging and comorbidities and chronic diseases, which comes not only with aging, but with the population and the medicine in general. So these are the challenges that healthcare systems are facing. And I try to visualize it in this slide that you can see. On the left side, you can see how healthcare systems in the world are doing really. Their characteristics is they are reactive. They wait until people get sick and then they react. Their solutions are one size fits all, working on the average people. And they are centralized in hospitals, in primary care centers, in some centers that people should go there and then receive the services. They are more paternalistic, that the healthcare staff gives some advices to patients and the patients should follow them. And some of them, not all of them, are volume-based. On the other side, what are the reforms that are needed? You can see them on the right side. Versus reactive, what we wish for is more proactive, predictive, and preventive care, which acts before it happens, or predicted what's happening in future, so we can prevent it. Versus average or one size fits all, we can wish for personalized care, which tries to find the best treatment for the patient's need and status. Versus centralized, we have decentralized, which you can see a lot of capabilities over home care services now, which you can, in pandemic, it was very clear that we can take care of ourselves at home, but be under some control. So we don't need to be in the hospital to receive the care. We can be somewhere else. And paternalistic versus empowered. People are now taking more responsibility of their own care. They are asking a lot of questions. They want to be part of the decision and not just receiving some advices. And of course, we want to work for value-based, not just volume-based care. So AI has the potential to transform care delivery. How? I just try to mention some of them here. AI can support improvements in many aspects, in care outcomes, in patient experience, in access to healthcare services, in productivity and the efficiency of care delivery. And, you know, AI can help the healthcare providers to spend the time wisely. So AI can be used to manage, to do some administrative work, to free the time of the physicians and nurses to spend with the patients. That's the time that should be used patient to physician, and the rest can be taken by AI. So I try to look for some growing use cases of AI in healthcare. I just provided some examples here. You can see from the top, AI can be used as self-management tools to empower patients to know more about what they are doing and how they are working through their treatment plans, compared to others, compared to average people, and a lot of things that can be happen. Then symptom checkers, e-triaging, screening, digital pills, which is very interesting. They have been growing not as fast as the others because people are hesitant to eat some chips, which can then tell the physician that, okay, I'm eaten. But there are on the market, especially for chronic diseases, which you need to take a pill in a yearly or forever, then you might forget it. So it's good to know how you're doing. Then hospital management, disease diagnosis and prognosis, and of course readmission prediction. Why these things are possible now? Because you can see data is collecting everywhere, not only in the healthcare systems, but you are collecting yourself without knowing it through your smart watches, your apps, your sensors at home. So we have a lot of data collecting. Why not using them wisely to get to know what you're doing, about your health status and disease progression? When it comes to scaling AI in healthcare, people talk about 3 levels. In the first level is increasing the adoption, working on the low-hanging fruits, like administrative tasks, which doesn't necessarily affect patients directly, but free some time from the people to work more on patient physician communication. And image-based applications. If you have looked into the market, you can see a lot of AI works into or directs towards radiology, ophthalmology, pathology, those that works more on images, where AI can show its power. Then the second scale is enculturation, I call it. It's more democratizing care, more working on empowering patients, on self-management apps, and some of the expertise like cardiology, neurology, and oncology are more, acceptable in that stage. And the third stage, which we really wish for, that is to have AI as a clinical decision support tool. It's very important to show that AI is not going to replace anybody. Of course, some jobs will be disappeared as it has been disappeared over years, but it's important that we use the time of valuable people that we have in the healthcare system wisely, and the other times goes to with AI, just the administrative task. So AI in the third stage will be as an integral part of the care chain. So people adopt it and use it in practice. If you look at the healthcare statistics, staff, and how much they have shortage, WHO has presented in their, one of their reports that by 2030, we will have around 10 million shortage in healthcare staff, including nurses, midwives, and of course, physicians. But the thing is that the challenge is not if AI can have impact. The challenge is to ensure the adoption. and work on adopting it in the clinical routine. And it's very interesting to know that 70% of the healthcare practitioners' time can be just reduced or spent by AI. We don't need 70% of the time overall on different expertise, not just physicians, practitioners in general. So we can alleviate this work shortage by using AI in the places that can have its impact. Where? The quality of AI solutions, how can we work on the adoption? The adoption can have different, of course, layers. One important aspect is design. Human-centered design is a good solution in that. So design of the AI solution is off question, if it's of good quality or not. Performance, if it has the performance that is needed by physicians, if it has the accuracy that is acceptable. And the third, which is very important, is the transparency. In order for the physicians, nurses, or the users of the AI system to trust the system, is that they know how the decision has been made. And explainable AI is a good solution for that. Opening the black box to show that the reasons behind that decision, how it was made. At Halmstad University, we have a big research profile. We call it Kaiser Health, and it stands for Center for Applied Intelligent Systems Research in Health, which is funded by KK Foundation. And we work on these topics that I've talked. This project, or this research profile, is a collaboration between industry. You see the industries around this on this slide. Academia, which Halmstad University, and of course we need regions, and Region Halland is our partner in this project. And our vision is information-driven care. Through access to the valuable source of healthcare data that has been collected over years around patients, from monetary aspects to non-monetary aspects, so kind of a 365 overview over patients when they start to interact with healthcare system and what happened with them. And looking at the needs of the human, and human can be users, including patients, nurses, and healthcare practitioners, we start to look at the three main research areas here. Precision healthcare. We call it precision healthcare and not medicine, because precision medicine has been already used as this genomics and proteomics. People start to think about it. But by precision healthcare, we mean finding the right treatment for the right person at the right time. It's the definition of precision healthcare. So it's not just about proteomics and genomics. It's about every type of thing that you can define a person, including genomics, but also environmental aspects and history of your and family and a lot of things around the person. Then we define connected health, which is a kind of care democratization. As I mentioned, people are now willing to take more responsibility of their own care at home or outside hospital in general. And connected health try to focus on that. And then the third one is healthcare implementation. Try to understand the challenges for adopting the AI solution in practice. And lastly is the details. More details I wanted to present here is what is very important when it comes to information-driven care is looking at the history of what has happened to the patient, which we call it patient trajectory. If you look at the patient, what has happened, you can see here in the slide, from the time that the person has had some interaction with the system, we can have them in a trajectory way or journey way. So we can look at the aspects among what has happened with the patient and try to predict future based on what has happened in the past. So this was a short introduction about AI in healthcare and what we are doing at Halmstad University.
Thank you, Farzana. And
Thanks.
it's always tricky when you have this introduction. And I'm very glad that we can go deeper on Thursday, because you could talk about hours of this.
Yes.
The third speaker on the third area is Petko Karamochev from Industria, Bulgaria. A scale-up, he's a founder and director at Industria. And the third area is confidential computing. And Petko couldn't join us on site, so he's over link. So I hope that the technology is with us.
Good morning. Can you hear me?
Absolutely fine. Can you hear us?
Yes, of course. Can you see my slides as well?
Yes.
Oh, very good. First of all, good morning, Halmstad. Good morning, Halland Tech Week. Many thanks for the invitation, both Anna and Eric. Unfortunately, I wasn't able to be with you this morning. At the same time, we've said a little bit of fuel, which is great for the environment. I'll say just a few words about Industria, because we are a relatively unknown name in Sweden. And thank you, Eric, for helping us establish a base of operations there. So Industria started as a Bulgarian-based organization. Now we have a headquarters both in Sofia and in London. We work with a lot of regulated industries, trying to provide solutions in various markets, most of them related to the finance industry. So we have projects in banking, capital markets, insurance, and supply chain. I'll try to be as short as possible, but also to connect the presentation that I've prepared with the words by Freddie, Zara, and Farzana. So. I think I'm very happy to be and very lucky to be at the end. So anyway, back to Industria a little bit. So primarily we are focused on providing solutions in a couple of expertise areas. One of them is the so-called enterprise blockchain, which is something Sarah tackled a bit earlier. We're also very strong with this new technology called confidential computing that I'm going to discuss right now with you. We're also helping companies improve their processes, and we have a very strong user experience team. Just recently, we've started a couple of interesting projects related another usage of the blockchain technology, which is a central bank digital currency. As you know quite well, Riksbank in Sweden is already experimenting using enterprise blockchain technologies. I'm very happy that we are working for the same organization that is providing the services for Riksbank. We also have a couple of projects in the field of trade finance and electronic bill of lading, which is again based on the enterprise blockchain. Another very important area of the usage from the enterprise, not just for cryptocurrencies, is the smart legal contracts. Now, what's really interesting for this presentation is the topic for confidential computing. I'll try to be as concise as possible, and let us stay a little bit on this slide. And before kind of going into slightly more technical details, probably most of the audience would be relatively new to the topic of confidential computing. Let's discuss a little bit the problem. So what is the problem that we're trying to solve with the technology called confidential computing? We live, as the other speakers confirmed, and as everyone knows, we live in a very connected world. And we believe that the world will become more and more connected in the near future. So there's no enterprise that will be able to live outside of the connected world, outside of the cloud. We also see an exponential data growth. The growth of data is already doubling every couple of years. And we will see much more data coming with IoT and 5G. As Freddie mentioned, 50% of the companies in Sweden are already investing somehow in Internet of Things. We see that the cloud economics are prevailing at this stage. There was a recent survey saying that CIOs have to deal with kind of a less budget, with limited budget and resources. So therefore, the companies are moving more into the cloud to gain more speed and agility. So the cloud is the new paradigm. We also see that solution complexity increases. We see that somehow, again, from the same survey, 76% of the chief information officers are saying that the IT complexities makes it almost impossible to manage their performance. We also see a lot of regulatory push, a lot of requirements from citizens and businesses for business risk and exposure impediments. We see the GDPR, we see CCPA, we see a lot of stuff happening on the healthcare side. Now, in a nutshell, what is confidential computing? Just think about the green bar in your browser, and that you see the little lock there. So as a user, you think, oh, my data is safe. I'm transmitting data securely. Probably you've heard the SSL. You've heard the word encryption. You've heard a lot of things. The reality is that by far the information industry, the IT industry, was capable of securing or encrypting the data sent by the client, say me, towards the server, say Facebook, and the data in transit in between me and the server was secure, was considered to be secure. So therefore, the internet service provider is not able to break in and steal some of the parts of the data. This is why if you're texting on WhatsApp, if WhatsApp works, it says it's an end-to-end encrypted encrypted data. Now, at the same time, on the server side, you've heard about secure databases. You've heard about encrypting databases. But the problem is, what happens when the data is in use by the application on the server? And this is where the problem begins. Whenever you're sending a personal data to a server, you don't know how the server or the operator on the server, it might be a business entity, it might be another organization. How are they using the data on the server? This might be a personal identifiable information. It may be financial data. It may be a healthcare information. In the case of COVID, the tracking applications, the COVID tracking applications, I think a lot of companies and a lot of governments collected a huge amount of personal data, and we actually don't know how these companies and governments are going to use this data. Are they going to sell it to someone else? So we are thinking about also using mobile devices, Internet of Things, and point of sale systems. So in a nutshell, the confidential computing allows us as users, as clients of the platform, to be able to understand exactly how our data is used. And I have a kind of my own quote for this, which kind of resembles a little bit the feminist saying. So my data, my rules. I think the confidential computing is able to kind of solve such a problem. So before, just a little bit. Okay, it's a little bit smaller than I've expected, the font here, so I'll try to kind of a little bit explain of how the technology works. There are different ways of preserving data on the server and allowing customers to understand exactly how this data is used. Our approach is to use a technology which comes from Intel, which is called SGX. This is a little bit technical thing. It's called a trusted execution environment. This allows us to kind of know exactly what sort of algorithm, what sort of computer code is using our data. And this prevents the owner of the computer, even the operator of the computer, to influence the data and to influence the code. These trusted execution environments, they allow programs to run inside the secure enclaves, which are isolated from the rest of the computer they run on, which is great because confidential computing is created for the cloud environment. These environments also ensure that the data in the code can be processed without the owner of the computer gaining access to the raw data. Now, as an example with the AI in healthcare, there's a lot of kind of a recent talks about combining databases and data sets from various hospitals. Most of the hospitals are reluctant to share their data. Why? Because they don't know, will the operator of this data turn themselves into a new sort of a Facebook and collect data from different sources and then use it for their own purposes? That's the first thing. Second, they don't know exactly how this data is going to be used against, or they don't have the assurance. Let's put it in this way. Even if you trust the operator, that there might be a man in the middle, there might be another sort of attack or another vector attack that might be able to extract this information. We've heard a lot of about recent attempts for this data, for such data to be stolen. So the confidential computing protects and reassures the different hospitals in the network whenever they're sharing data for AI and machine learning purposes, that this data is going to be used in the right way without being used for any other purposes. Now, use cases, we can see various use cases. My company is working mostly on fraud detection, on market data aggregation. We also work on private order matching. It doesn't mean that we can limit the use cases that we're working on only on finance, but we're currently working on this one. At this stage, we're working a lot with different beneficiaries. We work with financial services firms. We work with analytical firms and companies that are leveraging AI. We work with various data providers, different exchanges, financial exchanges. We help companies with fraud detection and compliance software firms. We work with a few corporates on their POCs and with regulators. And probably last slide, the benefits of such implementation. Now, why would companies would like to implement, and organizations would like to implement the confidential computing? Is to process data from multiple parties to solve problem in the whole industry. So with the decentralization and especially requirements for regulation, whenever a data is sucked in from a single in a single compound, therefore this data could be processed with confidential computing. Customer data could be better protected, and assurances could be provided that the data remains protected when collected, shared, and analyzed. We can also help companies reduce time to market, access previously inaccessible customer data that wasn't shareable at that time. And this will create a new kind of a data sets for artificial intelligence without sacrificing privacy. We can also help companies streamline business processes whenever sharing their data. Of course, increase effectiveness of financial crime detection. There are many different cases in the insurance industries. And we would like also to provide transparent and fair price discovery in dark pools. Now, this was my last slide. I would like to thank you. At present, we operate in London, in Sofia, but hopefully very soon we'll see each other in Sweden.
Thank you so much, Petko. And we are running out of time, so we can't have the Q&A in this last session. But this was a teaser, and there will be more sessions this week and also during Halland Tech Meet and Halland Tech X. So thank you all for having this introduction, and I hope we will meet several times during the week and in the coming months and weeks. Thank you so much.
Thank you.
Thank you.